My name is Hayward, and I live in Balfron. I also have a young son at the local primary school. And I'm going to talk tonight about my reservations about what I see as the inappropriate siting of this particular development. Now, this was at the Endpower exhibition, and what this is a map of the noise distribution from the proposed development. My company designs and manufactures sonar arrays for underwater imaging, for surveying. I understand the maths well, I understand the cause and effect relationships, and I understand why it needs to be done. So when I saw this, I was amazed. My first reaction was, hey, this has got to be measured. And then I said, no, it can't be measured because they haven't built the wind farm yet. It purports to show that the noise emanating from the wind farm is within the environmental limits. To me, the simulation of the noise distribution from these very complex generators, in other words, the turbines, isn't straightforward. And I asked the developer how they produced the simulation. Now, they couldn't tell me that. How do you simulate these things? How do we actually go about predicting the noise distribution from your average wind turbine? And there are some major issues which really led me to the conclusion that this was not, in fact, feasible. Because, for a start, the amplitude modulation or the aerodynamic modulation, well, that emanates from the turbine tips, so it's believed. It's highly non-linear. Now, that's another way of saying that the underlying mathematics has not yet been solved. And without the mathematics, you can't do the simulation, you can't do the prediction. Wind turbines are situated in hilly areas, they're situated beside trees, they're situated beside rivers. All of these will influence the propagation. Now, the sound propagation just doesn't propagate through the air, it will also propagate through the ground. So you have a very complex propagation structure here. You've also got the weather. The wind will change it. If you can all imagine for a minute a very still pond, and you have two pebbles in your hand, and you throw one pebble into the pond, and you see the concentric rings spread out. Then you throw the other one in, and the concentric rings spread out from that one, and eventually they will interfere to produce a more complicated pattern. Well, when you've got these turbines, they interact in exactly the same way. You know, the main noise source, as far as I can glean, are infrasound and AM noise. AM noise is kind of higher frequency noise. Infrasound is the very low noise that you actually cannot hear, or most human beings can't hear it. And there's a real lack of underlying physics and maths to explain the propagation, the generation and propagation characteristics of both of these. You also have it's a three-dimensional problem. The turbines that we have here are roughly 125 metres from bottom to tip. Sound's being generated at various parts of that structure. You've got 9 of them interacting and also interacting with the land. In my business, we manufacture sonar arrays that can cost upwards of up to £500,000, sometimes more. Now, they are too expensive to do a lot of experimental testing in order to prototype them. So we use virtual prototyping. We use computer simulations. But in order to arrive at that, these computer simulations had to be verified by real data. The experiments had to be conducted at every level in order that we had confidence to use the simulations. But any computer simulation is what it is. It's a model, and any model is only as good as the data that you can put into it. So in the case of the wind turbine installations, how do you get the experimental data in order to corroborate theory? Well, it's very, very difficult and very costly. And because of the cost, it's not been done properly. And what you end up with are random sample measurements around a wind turbine installation, which purport to show that that's the noise generated by the structure. But these fields are so complex that you cannot use that, because you have to do a comprehensive field map. And that involves taking very fine samples. It's not good enough for someone to walk around a wind turbine installation and say, I can't hear it. They may be deaf, they might not have the range, and also they're not going to enough points in order to get an accurate evaluation of what the noise characteristics are. The technology to simulate these acoustic fields from wind turbine installations isn't there. Where we come from in our own development here, Balladalloch, we've got some of the biggest turbines in the world. We also have the proximity to the schools, 2 kilometres from the schools. And this really got me thinking, because I was thinking, how far does this propagate? 2 kilometres isn't very far away when you've got 9 of these structures and they're 125 metres from ground to tip. Just briefly go over some corroboration of what I'm trying to say. This data is taken from a report generated at the University of Salford to investigate amplitude modulated noise. I've cherry-picked these, obviously, but what they do say is that the science doesn't exist. And amplitude modulated noise, which is one form of noise, isn't fully understood. Here are some quotes I managed to dig out relating to vibroacoustic disease. Now, this is most often associated with the very low frequency sound or infrasound, which we cannot hear. So these are statements that are in the public domain, and they're actually very frightening. And then you see that we're starting to see statements relating to the allowable distance between a wind farm and habitation. Now, that depends on the siting of the wind farm, the type of the wind farm, but this appeared at an international conference in Lyon. Now, to say that significant noise from these installations doesn't exist is wrong. So this is a simulation I did of the Ballindallaghmoor site, and it's a bit different from Endpower's. Now, and what you have here are the 9 turbines. There's Balfron, and there's the school. Now, what you see here is a different picture from my pebble analogy. You see zonal areas of very, very low sound intensity. Now, any measurement taking place in these areas is going to reflect almost no noise from the wind farm. So if you've got your house sitting, let's say you're quite close to this, let's suppose you get a house sitting right in there, you might not hear anything under these conditions. But you could be sitting on one of the lobes where you've got not a lot of decay between that wind farm and the village of Balfron. And this would be I've not taken wind propagation into account here. So this is assuming that the installation is vibrating and the turbines are all vibrating, but they're capable of doing it in all directions. But this would be more representative of propagation, wave propagation that travels through the ground, which is not affected by the wind. Now, any measurements in here are going to be extremely difficult to do because of this very complex field pattern. You've got an extremely sophisticated structure in here. And how to take, I don't know how to take accurate measurement in there. It would require a lot of time and a lot of money, but it's very difficult. And also the factors that influence this distribution are the tonal content, the frequency of the sound, the spacing between the turbines, and critically the timing between the turbines and the wind direction, all affect it. And I can show you some of these as we go through. I'll try to go through these quite quickly. Now, this is a different noise map, and what I've tried to do here is take a kilometre from each turbine. So I've removed the bit in the middle and referenced all the sound map to the noise that would appear along that kilometre. And interestingly, that's just about the same as Jane's measurement, which was about 900 and something metres. And what you see here, there's the Balfron School. And the noise level there at the kilometre distance is comparable. This here is about 80% of the noise at that point. And that's for a particular frequency. And you can see this very complicated acoustic field pattern that's emerging here. We then change the frequency and go up. So I'm now going up in tonal content. And again, you get a different distribution. Here we have another one. This is an infrasound frequency. There's the school. And again, you're getting these quiet areas. And if we change that a wee bit, and all I've done now is change the same frequencies as before, is change the phasing of the turbines. So now they're all beating a bit differently. And there's a school. There's a school there. It's in a quiet area. And the measurement there would be fine. And this is where I'm coming from, though, when I say that the subjective data that's been taken to date is entirely inadequate. It's not appropriate to go and walk around a wind farm installation and say, "Hi, I can't hear anything," because it depends on the conditions at the time and where you are. The only safe way to ensure that noise isn't a problem is to move them far enough away. At present, there's no other way apart from that, apart from shifting them. Whether you agree with wind farm technology or not, there is really no other way. So if you ask me, do I believe in my computer simulations? And my answer is I cannot believe it because I don't have experimental verification that these are right. But I don't see the experimental verification in Endpower's, and mine are dramatically different from those of the developer. But if we could stick to some facts for a minute, and this is the conclusion I've come to, that the proposed site is 2 kilometres from 2 big schools. They're some of the biggest turbines in the world, and these are fact. The science and noise prediction and measurement around such installations is not complete. That's a fact. And there are known and recognised health issues related to turbine noise. That's a fact. So I have to ask, why Are we having these placed so close to the schools? This to me represents a very significant risk. And there's an easy way. You just don't put the wind farm there. Whether you agree with wind farm technology or not, this to me is an unacceptable siting. And here is what we have. This is really what I'm trying to say, but it comes from someone else. This Nina Pierpoint, who is a clinical physician in the US. And that really summarises a lot of it. Thank you very much.